Good morning, everyone. We are going to cover a new topic today, and we are going to be talking about factoring in zeros of polynomials, and specifically how to use the rational zero test to factor those ugly polynomials. All right, so let me tell you how the rational zero test works first. If I've got some polynomial, a x to the n, and of course a is our leading coefficient. Okay, that is our leading coefficient. Plus whatever the rest of this polynomial is, what's in between doesn't matter too much. What matters is what's at the beginning, the leading coefficient, and what's at the end, which is a constant. What we're going to use is the leading coefficient and this constant to help factor it. All right. And we must have integer coefficients. Okay, that's one rule that we have to follow. We have to have integer coefficients, and in case you forgot, integer coefficients are positive and negative whole numbers. All right. So here's what this rational zero test says. It says that I can find rational zeros by doing P divided by Q, where P is a factor of the constant term, and Q is a factor of the leading coefficient. I'm just going to put LC for short, the leading coefficient. And this test works really nice. Let me show you how it works. Let's say that my function, this is a great example to start with. Let's say that my function is 2x cubed plus 3x squared minus 8x plus 3. And you are asked to factor this thing and find any zeros. Okay? We want to factor and find zeros. Now, before I told you that we would try to split this thing in half and factor it when we had 4 terms. That won't work here. Okay, that will not work. So that's why we have to resort to another method. So the first thing that we have to do here is say, what are the factors of the leading coefficient? Well, it's the number 2. It's pretty easy. My factors are positive or negative 1 and positive or negative 2. Those are the only possibilities, because 1 times 2 is 2. All right. My only factors of 3 are positive and negative 1 and positive and negative 3. So now I can come up with a list of the possible zeros. And coming up with this list and organizing our work at the beginning is what really takes the most time. So look up here. Remember this up here? My possible rational zeros are the factors of the constant term over the factors of the leading coefficient. So my possibilities are going to be, I have to look at plus or minus 1 or plus or minus 3 over plus or minus 1 or plus or minus 2. The factors of the constant term go on top. The factors of the leading coefficient go on bottom. Now what we have to do is we have to come up with all the possibilities that could work. So first, obviously I could do 1 over 1. So plus or minus 1 is a possibility. And then I could do 3 over 1. So plus or minus 3 is a possibility. But then I could do 3 over 2. So I have to think of plus or minus 3 over 2 as a possibility. Try to zoom that or focus this a little bit. And also, we've already considered 1 over 1, but we haven't considered 1 over 2. So I could think about plus or minus 1 over 2 as a possibility. All of these are possibilities for factors of this polynomial. So here's the nice thing. All we have to do is synthetic division to find it out. Now, we put our factors, our coefficients of our polynomial inside, 2, 3, -8, and 3. And where do you start? Well, if it were me, I would start with 1, just because it's an easy number to start with, okay? So which one do you start with, positive 1 or negative 1? It doesn't matter. But what if I started with negative 1? Well, we do our synthetic division. So I bring down the 2. Negative 1 times 2 is negative 2. 3 combined with negative 2 is positive 1. Negative 1 times 1 is negative 1. -8 and negative 1 is negative 9. Negative 1 times negative 9 is positive 9. And this is 12, which means negative 1 is, I'm going to get a big red pen here, not one of the zeros. For it to be one of the zeros, I have to have a remainder of 0. If I don't have a remainder of 0, it's not one of the factors. We've actually talked about that earlier this year. Let's try positive 1. So at the beginning, you have a little bit of experimentation you got to do. Same coefficients. Let's do our synthetic division now. Bring down my 2. 1 times 2 is 2. 3 and 2 is 5. 1 times 5 is 5. -8 and 5 is -3. 1 times -3 is -3. And yay for us, we have a remainder of 0. That means that x equals 1 is one of the zeros. Big check mark. And that also means, let's look at what we have left here. This is 2x squared plus 5x minus 3. So if I am factoring this big long polynomial, factoring it will be this times this factor. Well, remember, if x equals 1, if I subtract 1 from both sides, I have x minus 1 as a factor. All right. And then we can factor or try to factor this quadratic right here. which looks to me like we need to do product sum. So we'll come over to the side. 2 times negative 3 is negative 6. I need two numbers that multiply to give me negative 6, but combine to be positive 5. So that's positive 6 and negative 1. So I have 2x squared plus 6x minus 1x minus 3. 2x times x plus 3. I want an x plus 3 over here, so I pull out a negative 1. So this thing factors into 2x minus 1 times x plus 3. And now we have factored this entire thing. Here's the factored version. And what are the zeros? X equals 1. If we set this equal to 0, I get 1/2. If I set this equal to 0, I get negative 3. These are the zeros. And doesn't this match up with all of my possibilities up here? If you look at my possibilities, and I look at what we found out as a conclusion, they all match up. All right. Now, before I let you work on the assignment, we should probably talk about what do you do if you have a quartic. What's a quartic? A quartic is a polynomial to the 4th power. So let's say that my quartic is x to the 4th minus x cubed plus x squared minus 3x minus 6. And we're wanting to factor and find the zeros of this quartic using this rational zero test. Well, my process is the same. What are the factors of the leading coefficient? Well, it's easy this time. It's only plus or minus 1. For negative 6, my possibilities are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And if you remember, we always put the possibilities of the constant term on top. All right. So if I put the possibilities of the constant term on top and this on bottom, that means my only possibilities are these numbers right here. Because the bottom number is going to be 1. So I'm going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And because the bottom number is the factors of the leading coefficient, that means all of my possibilities are just the top numbers, okay? The plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So all I really need are those numbers right there, all right? So I like using that for emphasis. I'll take that off now. So where do I start? Well, if you start with 1, that's always a good place to start. If you start dividing by 1, you have 1, negative 1, 1, negative 3, and negative 6. So you do your synthetic division, bring down my 1. 1 times 1 is 1. That's 0. 1 times 0 is 0. This is 1. 1 times 1 is 1. This is negative 2. 1 times negative 2 is negative 2. This is negative 8. 1 is not one of the zeros. So let's try negative 1 now. So if I try negative 1, 1, -1, 1, -3, -6. That's 1. -1 times 1 is -1. This is -2. This is +2. These two are 3. This is -3. This is -6. This is +6. That's 0. So x equals -1 is one of the zeros, which will also help us find one of the factors. So, well, look what I have left here. I divided a quartic, a fourth power, by x plus 1, basically. What I'm left with right here is a cubic. I've still got more work to do. So what I have to do is put these numbers down here, 1, -2, 3, and -6. And now I need to divide it by something. Well, I've already found -1, so why don't I try dividing by 2, one of my other possibilities. So I'll divide by 2. Remember, 2 was one of my possibilities that I found up here. All right. So I do synthetic division. 1, 2, 0, 0, 3, +6. I got lucky. X equals 2 is another one of the zeros. I have a 0 here. I have a 0 here. This is a quadratic. This is just x squared plus 3, which will not factor because it's not a difference of 2 squares or anything. So I'm ready to state my final factored form. It's x squared plus 3 times this would turn into x minus 2. It's working backwards. This would turn into x plus 1. So I only have 2 real zeros. You know why? What happens if I set x squared plus 3 equal to 0 and solve it? If I take this -3 over, I have x squared equals -3. I can't take the square root of -3. Okay? So this right here